Hey there. So in this question, we have been given a two-digit number and there are certain conditions accompanied by it. And by the way, this question is courtesy of Arun Sharma's Quantitative Aptitude for CAT, 8th edition. So credit where it's due, and let's get back to the question. Let's see how to solve it. Now, let's look at it the conventional way where we have to do it algebraically. If we have a two-digit number, we assume the digits to be x and y, right? Give me a moment. We assume the digits to be x and y. X is in the 10th place, y is in the units place. So the placement of the digit matters, and the number out of it will be 10x plus y, right? 10 times 10 times the 10th digit plus 1 times the units digit. Awesome. So we have that, and with that in mind, we need to know that the sum of the squares of the digits, the sum of its squares, which means we need to square x first, we need to square y, and then add them together, the sum of their squares. Exceed the sum of the squares, so the number is less than the sum of the squares by 11, which means when we subtract the number which is 10x plus y from the sum of the squares, we get 11, right? That's the first equation. And what will be, we have two variables, we need two equations, right? What will be my second equation? So let us say, okay, this is the condition, the two-digit number itself exceeds the double product by 5, right? Which means 10x plus y minus 2xy, the double product. Take the product and double it. Xy is the product of two numbers. And this is my equation 2. Now if I subtract these two equations, I get interesting. No, I don't want to subtract them. I'll get the number. Alright, I'll get, let me add the two equations instead. So if I add the two equations, the 10x plus y component gets cancelled, and I have x square plus y square minus 2xy is equal to 16, right? This is x minus y whole square is 16. X minus y is plus or minus 4, right? The square root of 16 is 4. We have to take positive and the negative square roots. So the difference between the digits is 4. We don't know which one is bigger, or which one is smaller, right? So we are still blindsided by this. And yeah, but if we look at the options, the difference between the digits is 4. So we have 15, we have 95, because these are the two numbers that matter actually. So it could be either of these, right? So instinctively my option goes down to this. Now, yeah, this is very good to do with the method of algebra, but if we actually have to do it for CAT, it's just the two numbers that this thing is irritating. It's just the two numbers that I have to consider, which is 15 and 95. So what is the sum of square of the digits for 15? I need the two things, sum of square of digits, I'll write it as SD. Then I need the number itself and 2 times the product of the digits. Okay, I'll write it as 2xy for now. So for 15, the sum of square of digits is 1 square plus 5 square, 1 square plus 5 square, which is 1 plus 25, which is 26. The number itself is 15. 2 times 1 times 5 the product, double the product, I get a 10, right? So the number is less than the square sum of its square by 11. 26 minus 11 is obviously 15, so that is valid for 15. Yeah, so and 15 is greater than it's this by 5, right? So the number is greater than the double product by 5. So yes, 15 works. 15 is one of the answers. And then what about 95? So 9 square plus 5 square is 81 plus 25, which is 106. Number is 95. So this exceeds 95 by 11. So the first condition works for 95. And 2 times 9 times 5 is 2 times 45, which is 90. And 95 exceeds 90 by 5. And so it works for 95 as well. So our answer should be both 15 and 95, straightforward A. But B has only 95. Okay, it's not just 95. C is a redundant option which says 15, 95 and 95, which doesn't make any sense. So C is out of the question. And in the option D, there's this fellow which is not a 2-digit number. So option D is also eliminated, right? So this is how we approach for CAT, where we just plug it in for the numbers that are relevant and not worry about anything else.